Hey Mustangs, in this video we're going to be taking a look at where new viruses come from. Whenever you hear the term emergent, you're talking about a new disease. So it can be a brand new bacteria, a brand new virus, but it's something that we haven't seen before, brand new. When we look at viruses, we're going to take a look at two possible ways a new virus could come about. One is zoonosis and the other is going to be viral sex. Before I go any further though, I want to make sure I stop and give credit where credit is due. A lot of the information, a lot of the pictures and the material that you actually see in this presentation actually comes from Joe Levine, who is a scientist and author of many textbooks. I was able to go to a webinar that he put on and I liked it so much and the information was so good, I wanted to make sure that I actually shared that information with you. So that's where this presentation actually came about. All right, so let's go ahead and get started with this. In order to understand where new viruses come from, we have to step back for just one sec and we have to take a look at virus specificity. Viruses, we know, are very specific as to which species they can infect, and even within that species, which cells they can actually infect. So if we take a look at this influenza virus here, if this is a human influenza virus, we know that it's only going to infect humans, and it uses its protein receptors to gain access to specific cells within the human. In this case, if we look, the protein receptors act like keys to gain entrance, so the keys have to match the locks here, which are the protein receptors on the cells. So this influenza virus can infect nasal cells and lung cells because it's that specific. It's that targeted to infect those types of cells. And that's really important to understand. And it makes it a little bit confusing though too. How can you have swine flu or bird flu, where it came from pigs, came from birds, if viruses are so specific? So let's go ahead and take a look at that. So it comes down to a thing called zoonosis. So zoonosis is basically where a disease is able to be transferred from one species to another. And this is actually pretty rare. The biggest thing it comes down to is the fact that some species spend more time together. The more time that they spend together, the more likely it is that they're going to exchange viruses with each other. At first, those viruses might not be able to infect each other, but the more time spent and those viruses constantly being passed back and forth, it's more likely that the virus will then mutate, because viruses mutate all the time. So here we're looking at a zoonosis for influenza viruses. Influenza is actually a group of viruses, just like I told you about coronaviruses. Coronaviruses is a group and there's several different types of coronaviruses. Same thing with influenza. So influenza is the group of viruses and there's many different types of flu viruses here. When we look at these lines, the solid lines represent the ones that are most likely to be transferred between species. The dotted is a little bit less likely, and then these other dotted ones are even less likely. So looking at influenza virus here, humans spend a lot of time around domesticated birds and domesticated pigs or swine. Not everybody, of course. I know I don't have any birds or swine, sorry, or any pigs, but there are some people that spend every single day of their life around these organisms because it's their job to breed and reproduce these organisms so that way there's food for everybody else. So because of that amount of time spent together, that's why it's more likely for humans to get certain viruses from birds and from pigs as well. Okay? Less likely from wild birds or horses or marine organisms, but it's still possible for them to transfer between these other guys here. Okay? So it's about the amount of time spent together, giving the virus that time to actually mutate because it's constantly being passed back and forth. Okay. Some examples of zoonotic diseases that you may have heard of: the plague. It's probably the most famous one there. Rabies, mad cow disease, West Nile virus. I know that was probably big when you guys were actually born. I remember when my daughter was born in 2004. That's when West Nile had really hit the United States, and it was kind of really scary at that time. I was really worried about her getting bit by mosquitoes and stuff like that. So that was a big one back in the day. Zika, that's a really current one that you've probably heard of. So all of these are viruses or bacteria that came from other species that transferred into humans because of close contact. All right, so let's take a look really quick at the example of the Black Plague or bubonic plague. This was back in the 1300s. So way back in the 1300s, they didn't know about bacteria and viruses. We hadn't seen them under the microscope and all that stuff. But they did know that if someone had it, it was likely that you might be able to get it from them. So they tried many different things in order to combat it. But because of their lack of knowledge and understanding about bacteria and viruses, it was very hard for them to beat it. What did eventually happen is something that we're actually doing right now. So social distancing. You might be tired of hearing about that, but it's nothing new. This is way back in the 1300s that they were actually practicing social distancing. So there were some kings, some leaders all around throughout Europe that started actually telling people, hey, you need to stay home. Don't go to church. Don't congregate together for any reason. Make sure you stay home. Just like nowadays too, there were people that kind of fought against it. People don't like being told what to do, so they fought against it. But eventually what we saw was more and more people started staying home out of fear, in this case, of the Black Plague. Because so many people were dying, people actually wanted to stay home. They were afraid to go out because they didn't want to contract the disease. All right, now let's take a look at viral sex. So viral sex, it's not two viruses getting together and having babies. So let's go ahead and take a look at what goes on with viral sex here. So with viral sex, it all comes down to kind of luck and coincidence for a virus. So here, let's use the coronavirus as an example. So let's say that there's one strain of the coronavirus, one type of a coronavirus here, and here's a different type of the coronavirus here. Now, if they infect an organism, they'll trick it into making more viruses for it, and then that organism can spread it to other ones and so on and so on. But every once in a while, one organism, its cells can get infected by two different versions or two different types of the virus. So what happens in this case is when the host cell becomes infected by both forms of the virus, here we have its RNA. So here's the RNA from one strain, here's the RNA from the other strain over here. Okay? We can see that they have slightly different instructions, so they don't have the exact same RNA instructions. But what happens is when the host cell actually starts reading the instructions and making these viruses, it accidentally mixes up all of the RNA. So what results is different possible combinations of instructions. So now you have different instructions that are going to make slightly different viruses. So here are some viruses that may result different combinations of the RNA here. And these viruses can be either deadly or benign. So sometimes when a new virus forms, the new instructions aren't really helpful to it. And so it's not very infectious, doesn't spread very easily, and that's lucky for us. Other times, it's the exact opposite. So it becomes actually very deadly. Those instructions allow it to be created in such a way that it's easier for it to infect cells, that it's easier for it to be spread. So that's when it becomes really deadly and scary for us. Now, the current coronavirus being passed around right now, SARS-CoV-2, is believed to, or is hypothesized, I should say. It's a hypothesis right now, let me get that clear, that it probably came from zoonosis and viral sex. So this cute little thing here is called a pangolin. And how did this pangolin get a coronavirus, and how did viral sex happen in the pangolin? It comes down to wet markets in China. So wet markets in China, these are markets that have tons and tons of animals of all sorts of different types, all close quartered together, all housed together. And not only do they have, animals that you're used to, cats, dogs, pigs, ducks, geese, all that stuff, but they also have rare and exotic animals too. So pangolins are actually endangered species, but the hypothesis right now as to where the SARS-CoV-2 virus came from is that a bat transferred a coronavirus to a pangolin. There was already another virus in the pangolin, and due to viral sex, a brand new coronavirus was formed. Right? So that's what that's where the hypothesis is right now. There might be new information that comes out, new evidence that comes out later on, but right now, what they've traced and followed back, it looks like this is where the virus probably came from. Okay? So what do we do about this current virus? We don't have a vaccine for it, so how do we move forward from here? How do we deal with this virus? Well, the best thing to do is look back at history. So if you really want to make sure that you don't make the same mistakes. Okay? Anybody who is ignorant or uneducated of history is doomed to repeat the same mistakes over and over again. And so we don't want to do that. Let's look back at history. Let's look back at how we have dealt with pandemics in the past and see what works. Let's use evidence to see what works. So here, not going back all the way to the Black Plague, but in this case, going back just to 1918, about 100 years ago. Okay? So in 1918, there was the Spanish flu. And that Spanish flu was an emergent virus at the time. It was probably created through viral sex, a brand new strain, something had new genetic information that allowed it to be more deadly than its predecessors. And here in this pandemic, 675,000 Americans died. And all around the world, it's estimated, because we didn't keep great records back then, but it's estimated that between 20 to 50 million people died worldwide. Okay, so 20 to 50 million people died worldwide because of this. Okay, so how did they deal with it? What worked back then? What worked and what didn't work? We can definitely learn a lot from that. So, one of the biggest things, guess what? Social distancing. Okay, social distancing was used across the whole United States and around the world, and some places did better than others when it came to social distancing. So, looking at the U.S. alone, places that social distanced right away had the best results with the fewest deaths. So here, St. Louis was one of the places that did one of the best, or did the best when it came to social distancing. Right away, they closed down schools, they closed down churches, and they had less deaths compared to many of the other major cities around the United States. One of the worst was Philadelphia. Philadelphia actually had some of the most deaths, and it came down, unfortunately, to a clash between politics and medicine. They were going to have a parade, and all of the medical professionals said, no, please don't do this, cancel it, because this flu is being spread around. This can be a really, really bad thing. Do not do it. And politically, they didn't listen. So they went through and they did the parade anyway, and the flu spread like crazy. And so they had some of the most deaths out of everywhere in the whole entire United States. So that's a really good example of how important social distancing can be. So again, social distancing isn't anything new. It's not some crazy extreme tactic that we've just created to try to deal with this. They did it back in the 1300s with the Black Plague, and they did it 100 years ago with the Spanish flu. So in science, we should learn by using evidence, and I think we definitely have that in this case. So that's something that we should definitely think about and consider.